Hi, my name is Anshu and welcome to my channel Bottleneck. This is the Data Structures and Algorithms series. In this series, we are going to learn and solve problems related to data structures and algorithms using Scala Functional Programming approach. In this video, we are going to solve n-Queen's problem. So, what is n-Queen's problem? N-Queen's problem is a classic puzzle that involves placing n chess queens on an n-to-n chessboard in such a way that no two queens can be in the same row, column, or diagonal. Backtracking is one common technique used to solve this problem. So, what is backtracking? Backtracking is a technique used in algorithm design to systematically search for solutions to problems. It involves exploring all possible choices and their consequences while respecting constraints, and it backtracks when a chosen path doesn't lead to a valid solution. So the chosen path is basically the path which we would need to place the values on, and that should satisfy the constraint. The constraint for us would be the same row, column, and diagonal. In one word, backtracking is a recursive algorithm. So the time complexity for backtracking depends on the number of recursive call with and the operations within each call. In worst case scenario, the algorithm explores all possible combination of queen's placement. The number of recursive call can be quite large, so it is upper bounded by O and cap n. Similarly, for the space complexity, it depends on the size of the board. So the board is represented as 2D array and the size is n into n, which contributes to the space complexity as O n cap 2. For queen, the number of queens 4 and the subboard size 4 into 4. The possible solution is 2. If we reduce the queen size from 4 to 3, there won't be any possible solution because in a board 3 into 3, a queen placed anywhere can trace across all the positions in the board, so that there is no solution for any number of queens less than 4. So we can run this solution what we are going to implement for queen value 4 or greater than 4. Alright, so this is the solution, how it is going to look like. Solution 1, where dot is the empty space, the space where the backtracking happened, and q is the position where queen will be held. Similarly, solution 2 will be different from the solution 1. So our objective is, for a given number of queen, find the number of solutions and also print the solution along. Alright, so let's implement the solution. Let's have a placeholder case class queen, which will have a row that will be of type int and a column which will also be of type int. Alright, now let's create the constraints like the method which will define whether it is safe or not. So it will be private dev is safe. Alright, this method is going to take queen and it is going to return a, it will be a type of queen, and it is going to return a boolean. So it will be checking across the all available queens. So let's make it queens. Now it will be checking within the sequence of queen. Alright, it will return a boolean. We will need another helper method. Alright, this helper method will be, we have to check. So what we are going to do is, each queen we have to check inside this queen and we have to compare. So let's create a comparison method. So let's name it as incheck. Let's make it private again, private dev incheck, where we will have first value q1, that will be type of queen, and q2, that will be again type of queen, and it is also going to return a boolean. Alright, now let's implement both of them one by one. Okay, now so this will be queens dot for all q not in check and the first value is going to be the queen itself and the new value and the iterative value as q. So we are going to check for each queen inside the queens whether the new queen can adjust or can have the position. Now here we are going to put the constant in this method. So how it is going to be? So q1 dot row equals to q2 dot row. So it means that whether the value is the queens are present in the same row. So we are doing negation of this. So it means not in the row 2. To simplicity, I have made it a negative comparison. We can do it vice versa. Alright, q1 dot column equals to q2 dot column. Alright, till here we have compared row and column. Now we will be comparing on the diagonals. So q1 dot row minus q2 dot row, taking an absolute value of this, equals to again q1 dot column minus q2 dot column and abs. Alright, so this will give me the whether the queen is safe or not. Now we have to implement the solution. So let's implement the solution. Private dev solve n queens. Alright, now watch closely. It's going to be n. This is going to be the number of queens and it is going to return sequence of queen. Alright, now inside this we will have a recursive method which will be backtracking and which will be comparing this is safe and placing the queen. So let's name it as place queens. So the job of this method is to place the queen with backtracking. Alright, so it is also going to return same thing, sequence of queen. Here if k equals to 0, it is going to return sequence of nil, else we will be calling this method recursively. So it is going to be place n queens k minus 1. So now every time the value is going to decrease, so we will call a flat map onto it. This flat map will hold the sequence of queens, so we need queens from each sequence and then we will be running on top of the entire board. So now we need the board itself. Alright, now we are doing a flat map here. In this flat map we will get the column number. So it is an array of array. So you can, if you are using for loop, you can relate it to I and j. So something similar we are doing with flat map, which is easy and simple to understand. That's the beauty of Scala. So val queen is equal to queen, and here we can write kclm. This is, we are creating a new queen. Now watch closely, we are going to do the comparison is safe, which is going to be queen comma queens. Alright, now if this condition satisfied, so we will be returning queens and we will be appending the queen itself. Alright, else nothing is going to return. So because we are only concerned about the position of the queen. Now let's call this place n queen with the value n. So initially it will call this method recursively and it will create sequence of nil. It will create a board and then it will start placing the queen, and it will also backtrack and it will check whether this position is safe or not. Now as we have implemented this solution, this will give us, so let's see what it gives us. Well, n is equal to 4. Alright, and val solutions is equal to solve n queens with 4. Let's print solutions dot for each println. Alright, now let's print and see whether we have implemented the solution correctly or not. So this will give us a sequence. Okay, so now this will give us a list of values. So this is basically a sequence. So we are getting two respective sequence, and this is not in a presentable format. So let's write a method so we can present this as a more readable format like the board of chess. So private def print solution, which will take solutions, and it is going to be sequence of queen. Alright, this is not going to return anything, this is just a method to print. Alright, so first we need a board, val board, which will be array dot fill, and this how what we are going to fill is we need a board as the size of solution itself. So solutions dot length, and the value that we need by default is dot. All right, so solutions dot for each. Now we have to populate the value of the queen in the board. So for each will go with the curly braces because we are going to implement a pattern match here. Case queen, and this will have the value as row comma or r comma c, and this will be board. Okay, and here it will be r minus 1, and this is going to be b minus 1, sorry, c minus 1, and this will be value q. Now we are using subtracting 1 because our chessboard will start with the index 1 and array will start with index 0. Eventually this can be fixed, but to keep this more realistic we have used the index of 1 with the chessboard. Alright, so now let's print the board dot for each, and now we are going to print for row. Each row will be printed, print ln. Alright, so it will be row dot, and then we have to convert it to string because everything will be in the form of sequence. Alright, now print ln to keep a space in between. Now let's okay, so first thing is we need to know the number of solutions that we have. So number of solutions, that will be dollar solutions and dot length. All right, now let's print the solution as well. Solution dot for each, and then print solution. All right, now let's run this. So expectation it is going to print the board with the queens and the length of the board itself, the length of the solution. So we have the solution as 2, the value is 1 2. So now we can see if this is starting index 1 2 3 4, and it will be 1 2 2 4, then 3 1 and 4 3 respectively. So this matches the exact board that we have created, and this is how the chessboard 4 into 4 will look like with 4 queens and the number of solution is 2. So this matches the initial assumption and the expectation. So this concludes the n queens problem. You can change the number of queens and test it further and improvise, and let me know in the comments if you have any further findings. If you enjoyed this video, please like and subscribe, and watch out for my next video. Thank you.